Hi everyone. So today we're going to talk about Ebeling choice box demonstration. During campus closure, I'm driving my car to the campus, to my lab, to show and record this demonstration. It was last weekend, Sunday. There's not so many people in the campus. It was quiet, so I walked on to the entomology building, and here is my lab. Ebeling choice box. So here we have Ebeling choice box. We have many of these in the campus. We kept it for classes and teaching, but Dr. Mike Rust have this, and we used it for many different types of studies. The box itself is about 1 foot by 1 foot, and there's a cover that only covers half of the box, and then we have clear plastic covers, and inside there's a divider, so the whole box is divided into 2 separate compartments. In the divider there is a hole, so you can actually stick the pen through. That allow the insect move between different compartments. Even after this cover is going to be placed on top of it and then sealed. On one side, we're going to use a cover to make the compartment dark. That compartment will be the dark compartment. And in contrast, the light compartment will have water source inside this vial with denture wick, so the water will be absorbed and then provided available for cockroach for drinking. And then as a food, we'll provide little pellets of dog chow, again in the light compartment. In a dark compartment, we can take out the lining, and this lining is going to be the substrate where various type of insecticide agents will be applied. And once that insecticide agent is dry, you can insert that back into the dark compartment. We don't want to have any runny insecticides, so we have to wait until it dries out. And then we put the covers on both compartments. And then only the dark compartment will get this opaque panel as a cover. Eventually, the insect will be introduced into the light compartment. Through the opening, the roaches will be able to move between dark and light compartments. They will get the food and water in the light compartment, but they might prefer the dark compartment for resting and during the light daytime. So once we introduce the insect in the light compartment, we'll count the number of insect in both compartments, live and dead, daily. So we'll count how many live and how many dead in the dark compartment. Same thing for the light compartment. Now we're going to talk about the insecticides we're going to be using for today's demonstrations. Those insecticides are provided in this handout. So I'll bring it over here and then we'll go over each of those insecticides listed on that handout. So the first one we have here is Black Flag, Gold, Roach, Barrier, and Killer. And this one is pressurized aerosol. So as you expect, there's a trigger, you push it, the things will come out as a fine droplets or the stream. And this one has permethrin as an active ingredient at 3.5% concentration. The next one we have here is a Phantom aerosol pressurized insecticides. Again, it's in some type of can here, and it has chlorophenapyr as active ingredients at 0.5%. So those two are pressurized aerosol, and this one is a liquid spray. You can easily find it in the store. Ortho Home Defense Perimeter and Indoor Insect Killer. And this one has bifenthrin 0.05% as active ingredients. And as you can see, it has roach, ants, and splatter, and it's one of the really common pesticide product you will see in stores. The next one, we don't have it here, but it's called Exciter, and it's one of those concentrated insecticides available in bottle for professional customers. It has pyrethrin and piperonyl butoxide as an active ingredients. Bifenthrin, pyrethrin 6%, piperonyl butoxide 60%. And this one, I don't have it here at the bottle. The next one we have is called Hot Shot Roach Killer Powder, and it's available in this kind of container, so you can squirt some amount of dust out. And it has orthoboric acid as an active ingredient, 99%. So it's almost a pure orthoboric acid, one of the boric acid type compounds. Another dust we have here today is a silica gel dry dye 69, 67. And it has silica gel and it has ammonium silicofluoride, and it's very floppy fine powder that is known to be pretty effective insecticidal compounds. It functions as a desiccant to kill insects. The next one we have for demonstration are controls. The first control is cellulose powder. Just like the previous two products we talked about, this one also comes in fine powder, but this is just clean cellulose, so we'll just use this as one of our controls. And then of course the final control will be untreated control, so the panel will be left untreated to compare that with other treatments as a control. So here we have Ebeling choice box, and again this side, the bottom liner, will be the area where this insecticidal agents will be applied. So for spray or pressurized aerosol, what you're going to do, you're going to hold this cans in certain distance from the panel, and you will evenly apply the spray deposits over it. Of course, we are not going to do that over the choice box. We don't want to contaminate the choice box, so this treatment needs to be done outside. It's going to be important to make even and homogeneous deposits. For the dust products such as silica gel, SG69, 67, or hot shot roach killing powder, or cellulose powder, we're gonna need slightly different approach. First of all, you're gonna take some aliquot out of this container, and then we're gonna need different way of applying that dust onto these panels. For that, I'll bring a large brush. So here I brought large brush. So let's imagine that we take some dust out into a little container, put the brush in it, apply the dust on the brush first, and then you will gently apply the dust particles along the panels like this, so that you will get relatively even deposits of the dust throughout the entire panel surface. Now we wait until all those liquid treatments are dry. We insert back into the dark compartment and then cover that part with plastic and then also opaque panel. As a study organism, we're going to use cockroach. This one you are seeing here is a brown banded cockroach we are keeping in the lab. For the actual study, we used German cockroaches, but this is just for demonstration purposes. As you can see, they have lots of dog chows at the bottom. They have a water bottle in the jar, so they're fine. When we're introducing The cockroaches, they will be introduced into the light compartment. First of all, you have to slide open that clean cover and then introduce termites. We're going to use 20 male insects, and then you're going to slide it back, and then you're going to seal that clear cover using some type of tape, and then it's ready to go. And the roaches will be able to get or access the dark compartment through that tiny hole. So that during the daytime they will look for the dark harvester sites, but at the same time they will be challenged because the dark compartment have insecticidal compounds. So every day we will count the number of insects in both compartments. We're going to count the number of live roaches and dead roaches on each compartment. This study will be simulating where the water and food is available in living space within the residential setting, but the roaches will have preferred harvester site in dark places such as underneath of the kitchen sink or wall voids, etc. And also, since we are not forcing the insect to touch the treated surface, which probably mimic the natural conditions more closely, this study will provide more realistic information regarding the efficacy of various types of insecticidal treatments.